Okay, here's 15.7. Myrtle Air Express decided to offer direct service from Cleveland to Myrtle Beach. Management must decide between a full price service using the company's new fleet of jet aircraft and a discount service using smaller capacity commuter planes. It is clear that the best choice depends on the market reaction to the service Myrtle Air offers. Management developed estimates of the contribution to profit for each type of service based on two possible levels of demand for service to Myrtle Beach, either strong or weak. The following table shows the estimated quarterly profits in thousands of dollars. And so we have our demand, and this is going to be strong demand. We get 960,000. This would be 670,000. Weak demand would be negative 490,000 or 320, depending on full price and discount. So what is the decision to be made? What is the chance event? And what is the consequence for this problem? And how many decision alternatives are there? Now, how many outcomes are there for the chance event? B, if nothing is known about the probabilities of the chance outcomes, what is the recommended decision using the optimistic, conservative, and minimax regret approaches? C, suppose the management of Myrtle Air Express believes that the probability of the strong demand is 0.7 and the probability of weak demand is 0.3. Use the expected value approach to determine an optimal decision. D, similarly, except we're going to use 0.8 and 0.2. And then E, use sensitivity analysis to determine the range of demand probabilities for which each of the decision alternatives has the largest expected value. All right, so for A, our decision to be made is to choose the type of aircraft service to provide from Cleveland. Then the chance event is the level of demand for the Myrtle Air service. The consequence is the amount of quarterly profit, how much we're going to make. Then there are two decision alternatives, either the full price and the discount service. And there are two outcomes for the chance event, either a strong demand or a weak demand. Now, if nothing is known, we need to do optimistic, conservative, and a minimax regret approaches. So I've redone the table down here so I can actually highlight in it. And so optimistic approach is going to be the maximum of the maximum profits. Well, that's going to be yellow, the maximum of the maximum profits. In the conservative approach, we want to use the maximum of the minimum profits. And so that's going to be the 320. So that's the discount service, whereas the other one was the full price service. Okay. Now for the mini-max, we have to do a little bit more work. So again, we start out with our table, and then we have to do some calculations. So the first is we have to find the maximum of each. So that's going to be the 960. We're going to take the 960 minus 960 and get 0. Then we're going to take 960 minus 670 and get 290. This column, we're going to take the 320, which is the max. So we take 320 minus 320, that's 0. And 320 minus 490, that's 810. Now what we're going to do is we're going to take the maximum in each row, and that's going to be the maximum regret. So over here, that's going to be 810. Here, that's going to be 290. Now, what we want to do for the mini-max regret approach is take the minimum of the maximum regret, which is going to be 290, okay? And so that's going to be the discount service. So that's going to be the mini-max regret approach. So we've got discount service, and full price service. Then part C, let's read that again. It says, suppose the management of Myrtle Air Express believes the probability of strong demand is 0.7 and the probability of weak demand is 0.3. Use the expected value approach to determine an optimal decision, okay? So I've written that down, our strong demand and weak demand, and we just plug it in and multiply in this table here. So it's going to be 0.7 times 960, and it's going to be 0.3 times a negative 490. We add those together, we get 525. Then we do the same thing for the discount. We take 0.7 times 670 this time, and 0.3 times 320. Add those together, we get 565. Now the optimal decision is going to be the maximum of the two expected values, and that's 565, and that's the discount service. And so with this setup for the demand, 0.7 and 0.3, discount service is going to be the way to go. The next problem said, okay, well now let's do it to strong demand of 0.8, weak demand 0.2. So all we do is we replace 0.7 and 0.3 with 0.8 and 0.2 on both of those, and we calculate it, and so we end up with 670 for the full price or full service and 600 for the discount service. And so the maximum of those two is the 670, which is the full price service. So with a stronger demand, we're going to actually switch over to the full price service. Now the last question, we're supposed to use sensitivity analysis to determine the range of demand probabilities for which each of the decision alternatives has the largest expected value. All right. So basically, instead of having one of these be an actual number, we're just going to say let P be the probability of strong demand. Well, if P is strong demand, what is weak? Well, 1 minus P, because if we think about this, if this is strong, and the way to get weak is 1 minus 0.8, which is 0.2. And so what we do now is we do the same thing as we did in part C and part D, except now we're going to use P and 1 minus P. And so we plug in P times 960 plus 1 minus P times a negative 490. Well, then we have to simplify here because that's just not obvious right away. So we get 960P, then we have a minus 490, then we have plus 490P. Okay, so now we got to look further. Now we just add those two together, we get the 1450P minus 490, and so that's going to be our expected value of the full service. Now we do the same thing except with the discount service. We have the P times the 670 now, and then 1 minus P times 320. And we distribute everything out. We get 670P plus 320 minus 320P. And now we add like terms. We'll get 350P plus 320. All right, so what will this tell us? Well, basically, when the two services are equal, then we're going to get the same expected value. Okay, so when we set those two values equal to each other, or just that set to equal, we're going to get the same expected value. So then what happens is when the P is larger, so when this actually is larger than the value found when they're equal, then what we're going to have is we're going to give the full service the advantage. Okay, so when P is larger, that's going to get the stronger demand higher, and so that's going to give us the full service the advantage. Now, if P is less than that P value we find when we set those two equal to each other, then that gives the discount service the advantage. Okay, so let's set them equal, and so in words, that's what we have here. The expected value full equals the expected value of discount. And then we just set those two equations or statements here we found equal to each other. And we solve for P, and we get P is equal to 0.7364. So if P equals 0.7364, the two decision alternatives provide the same expected value. So that's going to give us the same expected value for both cases. Now, so if we have P values below that, the discount service is going to be the best choice. And if we have P values greater than that, then the full price service is going to be the best choice. And so that's what it's asking for when it asks for the sensitivity analysis. We just have to use a P and then the 1 minus P and then solve and set the two expected values equal to each other. And then based on that, we can either say, okay, well, if it's greater than that value, we give an advantage to one. If it's less than, we give the advantage to the other. So hopefully that helps with 15.7.